Good evening. In the last lecture, we discussed definition of permutation and we obtained formula for NPR, that is number of permutations of n things taken R at a time. I'll explain that part once again. A permutation of n objects taken R at a time is an arrangement in a straight line of R objects taken out of n given objects. Actually, in the second part, we are going to discuss circular permutation also. That is, things will not be arranged in a straight line. Things will be arranged in circular fashion. Okay, but at present, we will consider arrangement in straight line. Now, total number of permutations of n objects, initially distinct objects taken R at a time, is denoted by NPR or PNR. So this is arrangement of n objects taken R at a time. Actually, formula for NPR is n into n minus 1 into n minus 2 up to n minus r plus 1. Logic is very simple. See, the first object can be arranged in n ways. Second in n minus 1, third in n minus 2. So that rth object will be n minus in bracket r minus 1, because for second subtract 1, for third subtract 2. So for rth subtract r minus 1 from n. So if you open the bracket, n minus r plus 1. But if you want to express this in terms of factorial, then NPR can be written as n factorial upon n minus r factorial. Clearly, r has to be less than or equal to n. What will be NPN? NPN is nothing but n factorial upon n minus n 0 factorial, which is 1. So n factorial. Do not waste time in finding, say, 7p7 or 11p11. Directly you can say 7p7 is 7 factorial, 11p11 is 11 factorial. Now, can you tell me the situations where permutation is used? Yesterday I explained the difference between an arrangement and selection. In case of permutation, order is important. So, formation of numbers using digits is the case of permutation, because order is important. 1 0 0 different from 0 0 1. Okay. Second, arrangement of letters in a word. DOG different from GOD. There are few people who see God in dog, but DOG, GOD are different arrangements. So, arrangement of letters in a word. Price distribution, order is important. Then standing or sitting in a row for photograph. P for permutation, P for photograph, P for price distribution, P for permutation. Okay. So in general, any ordered arrangement, in that case, we have to use permutation. Now, just give the title permutation and write this formula. Write down, give the title permutation. Now, definition will not be asked in exam. So just write down what is NPR. It is n factorial upon n minus r factorial, r less than or equal to n. Okay. And what is NPN? NPN is nothing but n factorial. Write down. And then tell me the value of P4, 11p3, 73p2. Tell me these three values. What is 10p4? 10 factorial upon 10 minus 4, that is 6 factorial. We have already solved sums of this type. Ideally, I should have written 10 factorial as what? 6 factorial into 7, 8, 9, 10. 6 factorial gets cancelled. That is why I have directly written 7, 8, 9, 10. 50, 40. 11p3, 11 factorial upon 8 factorial. After cancelling 8 factorial, 9, 10, 11, 990. 73p2, 73 factorial upon 71 factorial. After cancelling 71 factorial, 72, 73. So 5 to 5, 6. Exercise 3.3. Just listen to me, but please do write the solution after the lecture. Find n if np6 is to np3 is 120 is to 1. We have already solved sums of this type. The only thing was NPR was not mentioned. So NP6 upon NP3 is given to be 120 upon 1. What is NP6? N factorial upon n minus 6 factorial. What is NP3? N factorial upon n minus 3 factorial. And this is in the denominator. N minus 3 factorial goes in the numerator. So n factorial gets cancelled. Same logic, which is greater. If you cannot make it directly, take some natural value of n, say 10. 10 minus 3, 7. 10 minus 6, 4. So numerator is greater. Factorial of greater can be expressed as factorial of smaller. Go on adding 1 unless you get greater. When I write, I see that numerator is written as n minus 6 factorial into, go on adding 1 unless you get greater. So from left to right, they write from right to left. Same thing. Now n minus 6 factorial gets cancelled. Some students have habit of opening all the brackets. Remember, here we deal with natural numbers. So what is LHS? LHS is product of 3 consecutive natural numbers. See, actually I should not say consecutive because they are writing in descending order. When I write the numbers in increasing, that is ascending order. Okay. So from right to left, these are consecutive numbers n minus 5, n minus 4, n minus 3. So express 120 also in that fashion. 120 can be written as 4 into 5 into 6. So 9 minus 5 equal to 4. Okay, what they have done? Why? It's not required. This is not at all required. Just mention. See, that is why when I write, I can say that n minus 5, n minus 4, n minus 3 are consecutive natural numbers. So we have expressed RHS also in that fashion. So there is no need to write this. You can directly say n minus 5 equal to 4. So n equal to 9. Second, find m and n if m plus n p2 equal to 56 and m minus n p2 equal to 12. M plus n p2 is m plus n factorial upon m plus n minus 2 factorial. It is 56. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. So this gets cancelled. Note that these are consecutive natural numbers. Why I am saying consecutive? Because how to get the next natural number? Add 1 to previous one. Simple. Right? So express 56 also in this fashion. See, do not write 8 into 7 because I am saying consecutive. 7 comes before it, right? And therefore, you have to say 7 into 8. Now that gives me m plus n equal to 8. This is first equation. Also, m minus n p2 is 12. So m minus n factorial upon m minus n minus 2 factorial is 12. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. Cancel this. Note that LHS is product of 2 consecutive natural numbers. So express 12 also in that fashion. In exam, you have to write this, that like LHS, we express RHS also as product of 2 consecutive natural numbers. So m minus n is 4. Add 1 and 2. So 2m is 12. M is 6. That gives me n equal to 2. So this is the answer. Third one, find R if 12p R minus 2 is to 11p R minus 1 is 3 is to 14. Same logic. So use permutation formula. Then which is greater? 14 minus R factorial is greater. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater number. Here they work from right to left. We work from left to right. Same thing. So you get this. 14 minus R, 13 minus R equal to this. Now I would have written 13 minus R into 14 minus R, consecutive natural number. So express 56 also in that fashion, 7 into 8. So that gives me 13 minus R equal to 7. So R equal to 6. Oh, this is not at all required. R equal to 6. Fourth one, show that n plus 1 into npr equals n minus r plus 1 into n plus 1 pr. LHS, n plus 1 into, what is npr? N factorial upon n minus r factorial. Factorial of any number into immediately next number is factorial of next number. Take particular value. Suppose n is 10. So 10 factorial into 11 is 11 factorial. Simple. Denominator as it is. Now RHS, n minus r plus 1 into this. This is n plus 1 factorial upon n plus 1 minus r factorial. Consider denominator. Factorial of any number is factorial of 1 less. Subtract 1 from this. So n minus r factorial into that number. Now this is 1 and the same. So gets cancelled. N minus r plus 1, n plus 1 minus r. So what remains is n plus 1 factorial upon n minus r factorial. So LHS equal to RHS. Fifth one, how many 4-letter words can be formed using the letters in the word Madhuri if letters can be repeated? Second part, letters cannot be repeated. Let me explain first. Now there are how many? 7 different letters in the word. Not a single letter is repeated. Okay. And we have to form 4-letter word. Now first part, repetition is allowed. So first letter can be arranged in 7 ways. Second, 7. Third, 7. Fourth, 7. So 7 raised to 4. These are the number of ways. In second case, repetition is not allowed. Means what? This is permutation of 7 things taken 4 at a time. So the number will be 7p4. Okay? Write the solution. There are 7 different letters in the word Madhuri. There are 7 different letters in the word Madhuri. And we have to form 4-letter words. And we have to form 4-letter words. First part, A part. If repetition of letters is allowed, then total number of words equal to. See, some students think words means dictionary word. No, actually arrangement is the better word because each will not have meaning. Okay. Yes. So A part, if the repetition of letters is allowed, then the total number of words equal to 7 into 7 into 7 into 7. So tell me, I think 2401, 7 into 7 into 7 into 7 equal to 2401. So that was part A, 2401. Now part B. As repetition is not allowed, as repetition is not allowed, number of words equal to 7p4. So tell me what is the value? 7 factorial upon 3 factorial. So 4 into 5 into 6 into 7. So comes out to be 840. Actually, we have used fundamental principle only. First can be arranged in 7 ways, as repetition is not allowed. Second, 6, third, 5, and fourth, 4 ways. So by fundamental principle of multiplication, the required number is 840. Right. Sum number 6. Determine the number of arrangements of the letters of the word algorithm if 4 parts are asked. A. Vowels are always together. B. No 2 vowels are together. C. Consonants are at even positions. Fourth, D part, O is the first and T is the last letter. Actually, you should know that out of 26 English alphabets, 5 are vowels. Which 5? A, E, I, O, U, and remaining 21 are consonants. Okay. Now, try to find the answers and type your answers in chat box. Okay. Don't write. First, I'll explain. In the word algorithm, there are how many letters? 9. Okay. Now, vowels should be together. How many vowels? O, A, I. 3 vowels. Okay. So, see the logic. We consider 3 vowels as a single letter. Let me explain first. If you have any difficulty, you can ask me. When I say 3 vowels as a single letter, by that I mean one group. So this single letter and remaining 6 consonants. So 7 letters are to be arranged. This can be done. This can be done in how many ways? 7 factorial ways. 7p7, that is 7 factorial. Now these 3 vowels can be arranged among themselves in how many ways? 3 factorial ways. So what is total number of arrangements? 7 factorial into 3 factorial. I'll repeat this part because many students, they say, how can we consider 3 letters as a single letter? By this I mean these 3 move together. And see, that is why I am not saying just 7 factorial. I am multiplying it by 3 factorial. So for each of these 3 factorial, 7 factorial possibilities. Okay. So this is first part. Now second part, no 2 vowels are together. This is interesting. See, there are how many consonants? 1, 2, 3, 4, 5, 6. Let me explain, don't write. So 1, 2, 3, 4, 5, 6, 7 means 3 vowels have 7 possible positions. So they can be arranged in how many ways? 7p3. See, these are 6 consonants. Now 3 vowels can have 5 places between 6 consonants and 1 place at each end. That is in all 7 places. Consider any 3 places. You will notice that no 2 vowels are together. So 7 places, 3 vowels. So they can be arranged in 7p3. Now arrangement is not yet complete. We have only arranged vowels. So 6 consonants are to be arranged. They can be arranged in how many ways? 6 factorial ways. Okay. And therefore 7p3 into 6 factorial. I hope you are getting this. This is the second part. Now third part. Consonants are at even positions. Now in the word algorithm, even positions are 4th, 2nd, 4th, 6th. And in the word algorithm, even positions are 4 and consonants are 6. How many letters are there? 9. Yes. So 4 even positions. Now number of arrangements in which 6 consonants occupy 4 even positions will be what? 6p4. I repeat this part. What is the requirement? Consonants are at even positions. So second, fourth, sixth and eighth. These 4 even positions. But number of consonants is 6. So total number is 6p4 ways. After that, we are left with how many? We are left with 5 letters. So they can be arranged in how many ways? 5p5, that is 5 factorial ways. So this is part C. Don't worry, we are going to write detailed solution. So at that time, I'll explain this part again. Now in D part, what is requirement? O is the first letter and T is the last letter. So first is fixed, last is fixed. Means we have to arrange remaining 7 letters. They can be arranged in 7 factorial. Okay. So this is about the solution. Now we will write detailed solution. Start writing. Solution. In the word algorithm, in the word algorithm, there are 9 letters. There are 9 letters which include 3 vowels, and 6 consonants. In exam, all 4 will not be asked. Only 1 or 2 will be asked. Now A part. We consider 3 vowels as a single letter. We consider 3 vowels as a single letter. Then this letter and remaining 6. Then this letter and remaining 6. That is 7 letters. That is 7 letters can be arranged in 7p7 equal to 7 factorial equal to 5040 ways. 5040 ways. Also, 3 vowels can be arranged. 3 vowels can be arranged in 3p3 equal to, also 3 vowels can be arranged in 3p3 equal to 3 factorial equal to 6 ways. Therefore, total number of arrangements equal to, 5040 into 6 equal to 30240. 30240. B part. Now just draw this. You need not use pencil. Just this much. Or I should have said, write this. As, write down, as no two vowels are together, as no two vowels are together, three vowels can have five places between six consonants, and one place at each end, that is in all 7 places. Therefore, they can be arranged in, see on the screen, they can be arranged in 7p3 equal to 7 factorial upon 4 factorial equal to 210 ways. Also, 6 consonants can be arranged. 6 consonants can be arranged amongst themselves in 6p6 equal to 6 factorial equal to 720 ways. 720 ways. Therefore, total number of arrangements equal to 210 into 720. It comes out to be 1,51,200. C part. There are 4 even positions. Inside the bracket, 2nd, 4th, 6th and 8th. Inside the bracket, 2nd, 4th, 6th and 8th, bracket complete. And consonants are 6. See, the meaning is, if it is an even position, it must be occupied by a consonant. So 2 consonants will be at odd places because number of consonants is 6 and number of even positions, that number is 4. Okay. Therefore, number of arrangements equal to 6p4 number of arrangements equal to 6p4 equal to, what is that number? 6 factorial upon 2 factorial. So 360. Now, remaining 5 letters can be arranged. Now remaining 5 letters can be arranged in 5p5 equal to 5 factorial equal to 120 ways. Therefore, total number of arrangements equal to 360 into 120. So 43,200. I hope you are writing this. D part. O is the first and T is the last letter. O is the first and T is the last letter. Remaining 7 letters can be arranged. Remaining 7 letters can be arranged in 7p7 equal to 7 factorial equal to 5040 ways. 5040 ways. Seventh, in a group photograph, 6 teachers are in the first row and 18 students are in the second row. There are 12 boys and 6 girls among the students. If the middle position is reserved for the principal and if no 2 girls are together, find the number of arrangements. Okay. Write the solution. I'm sure you will understand it. See, that principal is not amongst 6 teachers. 6 teachers and a principal. Okay, write down the solution. There are 6 teachers. There are 6 teachers, comma, 1 principal, comma, 12 boys and 6 girls. Next line. As position of the principal is fixed. As position of the principal is fixed, six teachers can be arranged in 6p6. 6 teachers can be arranged in 6p6 equal to 6 factorial ways. Just keep this as it is at present. 6 factorial ways. Next line. As no 2 girls are to sit together, as no 2 girls are to sit together, comma, they have 11 places between 12 boys. They have 11 places between 12 boys and one place at each end. And one place at each end, that is in all 13 places. That is in all 13 places. Therefore, 6 girls can be arranged. 6 girls can be arranged in 13p6 equal to 13 factorial upon 7 factorial ways. Just write this much. 13p6 equal to 13 factorial upon 7 factorial ways. Also, 12 boys can be arranged. Also, 12 boys can be arranged in 12p12 equal to 12 factorial ways. 12 factorial ways. Therefore, the total number of possible arrangements, therefore, the total number of possible arrangements for a group photograph, total number of possible arrangements for a group photograph equal to 6 factorial into 13 factorial upon 7 factorial into 12 factorial. Now we will simplify this much. 6 factorial as it is, 13 factorial as it is. What is 7 factorial? 6 factorial into 7, 12 factorial as it is. So it is 12 factorial, okay, into 13 factorial divided by 7. That's it. Right. Sum number 8 is for homework, but I'll definitely tell you the solution in the next lecture. Find the number of ways so that letters of the word history can be arranged as A part, Y and T are together. B part, Y is next to T. C part, there is no restriction. D part, begin and end with vowel. E part, end in ST. Okay. F part, begin with S and end with T. So for the first part, answer is 1440. For second, I think it is 720. You can of course check. Then C part 5040. D part is, I think, 240. Then E part is 120. So is F. Okay. So this is for sum number 8. Sum number 9. Find the number of arrangements of the letters in the word Solapur so that consonants and vowels are placed alternately. In the word Solapur, the number of letters is 7. O, A, U are vowels, and what are the consonants? S, L, P, R. Since consonants and vowels are placed alternately, the 4 consonants must occur at 4 odd places and 3 vowels must occur at 3 even places, because number of vowels is less than number of consonants, right? Now 4 consonants can be arranged in 4p4, that is 4 factorial ways. and 3 vowels can be arranged in 3p3, that is 3 factorial ways. So number of arrangements in which consonants and vowels are placed alternately is 4p4 into 3p3, that is 144 ways. See, you cannot say that we will start with how many 7 letters? We will start with vowel. Not possible, because they are to be placed alternately. Is that clear? So number is 144. 10. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 4, 5, 6, 8. If A, digits can be repeated, B, digits cannot be repeated. Actually, we have solved this using fundamental principle, but now we will use permutation. Okay. Now note that degree of difficulty is reduced because given digits do not include 0. Write the solution. There are 6 different digits. There are 6 different digits inside the bracket. 0 not included. 0 not included. Bracket complete. We have to form 4-digit numbers. We have to form 4-digit numbers. A part. As repetition is allowed, each place can be filled in 6 ways. Each place can be filled in 6 ways. Each place can be filled in 6 ways. Therefore, 6 into 6 into 6 into 6. What is the product? 1296. Numbers can be formed. Right? Numbers can be formed. B part. As repetition is not allowed, as repetition is not allowed, 6p4, find out 6p4 equal to 6 factorial upon 2 factorial. So 3 into 4 into 5 into 6 equal to 360 numbers can be formed. 11th, how many numbers can be formed using the digits 0, 1, 2, 3, 4, 5 without repetition, so that resulting numbers are between 100 and 1000. The numbers between 100 and 1000 are 3-digit numbers. 100's place can be filled by 1, 2, 3, 4 or 5. 0 cannot occur there. So can be filled in how many ways? 5 ways. Now repetition of digits is not allowed. So tens place and units place can be filled from the remaining 4 non-zero digits and 0, that is from 5 digits, in how many ways? 5p2 ways. You may ask me, can we solve this without using permutation? Yes, you can. Because what is 5p2? 5p2 is again 4 into 5, right? So required number is 5 into 5p2, that is 100. So 100 such numbers can be formed. So that's it for today.